By the end of the second week of development, the bilaminar embryonic disc, consisting of the hypoblast and epiblast, has formed. Throughout the third week of development, this bilaminar disc differentiates to establish three primary germ layers, in a process known as gastrulation. Around 15 days after fertilization, a thickened structure forms along the midline in the epiblast near the caudal end of the bilaminar embryonic disc. This is called the primitive streak. At this stage, the formation of the primitive streak defines the major body axes of the embryo, including the cranial end towards the head and caudal ends towards the tail, as well as the left and right sides of the embryo. At the cranial end of the embryonic disc, the primitive streak expands to create a primitive node which contains a circular depression, known as a primitive pit. This depression continues along the midline of the epiblast towards the caudal end of the streak, forming a primitive groove. Once formed, cells of the epiblast migrate inwards towards the streak, detach from the epiblast, and slip beneath it into the interior of the embryo. This process is known as invagination. The first cells to invaginate through the primitive groove invade the hypoblast and displace its cells. The hypoblast cells are eventually completely replaced by a new proximal cell layer, which is referred to as the definitive endoderm. By day 16, the majority of the hypoblast has been replaced. The remaining cells of the epiblast are now referred to as the ectoderm and forms the most exterior distal layer. Some of the invaginated epiblast cells remain in the space between the ectoderm and newly formed definitive endoderm. These cells form a germ layer known as the mesoderm. Once the formation of the definitive endoderm and mesoderm are complete, epiblast cells no longer migrate towards the primitive streak. Throughout gastrulation, the ectoderm continues to form from the cranial to the caudal end of the embryo, establishing three distinct primary germ layers throughout the whole embryonic disc. The gastrulation process is finally complete.